we tried to explain how can you prepare a molar solution. So here now it is a standard solution. It's different from molar solution. So the procedures for determination for preparation of standard solution is that one, you must first calculate or find the number, the amount, find the amount of a substance, amount of a substance used to prepare the standard solution. And here is that the volume and the concentration of that reagent must be considered, should be considered. So after finding out the amount of a substance, then you have to work out on the relative molecular mass of the substance. Now you may ask yourself, why this part of working on the molecular mass of a substance? The molecular mass of a substance now will help you to determine the mass of a substance needed to be measured. So here you have now to determine, calculate the mass of a substance to be measured. The mass of a substance to be measured. Now, how do we calculate the mass of substance to be measured? Remember that from number of moles is equal to mass over molar mass. My dear students, you remember this concept from mole concept, that number of moles, since I have said that find the amount of a substance, that is the number of moles. So to get the mass required to be measured will be equal to number of moles then times the molar mass. And a molar mass is obtained from the formula of that compound. But also, we have talked about the concentration and the volume. If you remember from concentration, which is molarity, molarity is equal to concentration in grams over molar mass. So here you can find the concentration of that substance by taking molarity times the molar mass. But that concentration will be its units in gram per liter. So you'll know how much of a substance to be measured and dissolved in 1 liter. So that is now these are the formula that you can use to determine the mass of a substance to be measured for preparation of standard solution. Now the next procedure from there, after having the mass, let's say that you have found the mass of a substance to be measured, which is, let that the mass obtained is equal, let's say, is 10.6 gram. And let us consider if our primary reagent is, our primary reagent or primary standard is sodium carbonate, and you have obtained the mass to be measured is this one. So we are preparing the standard solution of sodium carbonate. So you have also, when now measuring this, you have also to measure the mass of a device or apparatus that will be used to measure that substance. It can be a petri dish, so you have to measure the mass of a petri dish, and after measuring the mass of petri dish, then you add with the mass of our primary standard, which is sodium carbonate. So let's now say that after measuring, you have the mass of petri dish to be used equals to, let's say, is 10.0 gram. So on the, when measuring now, the 10.6 gram of our primary standard using the petri dish, that means your device that you'll be using in measuring, it can be an electronic balance, or it can be a chemical balance or beam balance. So here is that the mass now of the reagent, then plus the mass of petri dish, the mass of petri dish should read 10.6 plus 10.0, that will be 20.6 gram. So now, after measuring the amount of a primary standard reagent that you want to prepare its standard solution, then now you transfer the mass into a beaker. After transferring the mass into a beaker, you have to rinse the petri dish with water, and that water also should be transferred into a beaker containing our substance. So after transferring it into a beaker containing our substance, then you can proceed now dissolving our primary standard. So make sure that all the substance or the primary standards have been dissolved into that beaker. So after dissolving it, so here we have to dissolve the reagent into a beaker. Then after dissolving it, transfer the content into a volumetric flask. So after transferring it into volumetric flask, you have to rinse the beaker that contained that reagent, and the water that have been used to rinse, you have also to transfer it into volumetric flask. From there now you have to fill, to add the water into the volumetric flask. Add the water into the volumetric flask up to near the mark, near the mark of that volumetric flask, which means that if this is a volumetric flask of 1 liter, have a mark here where if it is of 1 liter, it means that once you fill the solution up to this mark, it will be 1 liter of that solution. So you may fill it up to, let's say, this point. From there now, you can use a dropper to add more water. Up to the meniscus. Now, after doing that, then you have to stopper the flask. Then after stoppering the flask, you have to put up, down to ensure homogeneous of the solution. From there now, you can label your solution. And in labeling your solution, you have to show the concentration of that solution, so you can determine the molarity of that solution. For example, since we are talking about the sodium carbonate, taking an example of sodium carbonate, let's say you have prepared of 1 molar or of 0.1 mole, or you can just write it 0.1 mole, then sodium carbonate. So that is now how you can prepare a standard solution. So you will be now having the standard solution of sodium carbonate that can be now used to standardize other reagents, which we call them as secondary reagents. So sulfuric acid, dilute hydrochloric acid, dilute sodium hydroxide, those are known as secondary standards because their concentration are being obtained from the primary standards or from the standard solution. Now, my dear students, let us now consider how can you prepare now the solution or the standard solution of those solution which now needs to use the standard solution of primary reagents. Normally, for substances or for chemicals that appear in solution, which means they are being bought from shops or purchased from shops in terms of volume. Now, how can you prepare those solutions in according to the concentration that you have been asked to prepare? This is so simple. What do is that normally the solutions are usually written with a certain specific information on the bottles carrying the solution. So the solutions have informations, have some basic informations on the bottle carrying those solutions. Let us consider, let's say you have a bottle for sulfuric acid, which is now our stock solution. Normally, this bottle will have the following information. We have the percentage purity of the acid. For example, for sulfuric acid, the percentage purity, which is weight by weight, is 98%. You also be provided with the density. For sulfuric acid, the density is 1.80 gram per cubic centimeter. And also will be given the relative molecular mass of that solution. For sulfuric acid is 98. Now let's say that you have been asked to prepare 1 liter, which is 1,000 cubic centimeter of 0.1 mole sulfuric acid. So normally the reagent bought from or purchased from shops do not contain or do not have the concentration. The concentration is not indicated. So what do? We usually prepare this solution by a process known as dilution. So if we use dilution in preparing them, that means you need first to calculate the molarity of the concentrated solution or the molarity of the stock solution. So here we have to work out on determining the molarity of this solution that will be in that bottle. So for considering our example, which is sulfuric acid, is that first you have to calculate the molarity of our solution, which is now is the stock solution of our stock solution. How do you calculate it? Since we have their percentage purity in the density, here it means that the density indicates that 1.8 gram of sulfuric acid is present in 1 cubic centimeter. So what about this percentage? What is this percentage in this density? So what do you do here is that first to calculate the mass or concentration, the mass or concentration of 98% of sulfuric acid in 1 cubic centimeter. So what do? It is just simple. You just take 98 over 100, which is the percentage, then times 1.8, which is the density, 1.8, then gram per cubic centimeter. My dear students, this is simple. So take your calculator now and find that concentration. Okay, my dear students, now if we calculate 98, then divide by 100 times 1.8, you'll have 98 divided by 100, then times 1.8. What you get? We get 1.764. So this is gram now will be present in 1 cubic centimeter. So the concentration, now the concentration of this solution is measured in 1 liter. So if 1.764 gram is in 1 cubic centimeter, then what about in 1,000 cubic centimeter, which is 1 liter? So you just cross multiplication. So if you cross multiplication, then it will be this one 1.764 will be times 1,000, then divided by 1, then getting up the concentration now in gram per liter of the stock solution will be equal to 1764. This is gram per decimeter cubic. My dear students, from there now we can find its molarity. So from molarity, which is equal to concentration, then divided by relative molecular mass. And the relative molecular mass of sulfuric acid is found on the bottle of that stock solution. So here concentration is 1764, then gram per decimeter cubic, then you divide by molar mass of sulfuric acid is 98. So if we calculate it, divide by 98, you end getting up the concentration, which is 18.0, then this is molarity. So this is the molarity now of the stock solution in that bottle. So from that point, you can go now to the dilution law. So in dilution law, so from dilution, you remember this concept, on more concept, is C1 V1 is equal to C2 V2, whereby C1 V1, C1 stands for the molarity of the concentrated solution, and the V1 stands for the volume of the concentrated solution to be measured now, and C2 stands for the molarity of the dilute solution you are supposed to prepare, and V2 stands for the volume of the dilute solution. Now here to find now, because we are now looking how much of the volume are you supposed to measure from that stock bottle, and how do you do that now? It means that you are looking for the volume of the concentrated acid that should be measured and diluted into a liter of a solution. So here that V1 now will be equal to C2 V2 over C1. So our volume of concentrated sulfuric acid to be measured from the stock solution, C2 is the molarity, where we have asked you to prepare 0.1 more. Then will be times the volume is 1 liter, which is 1,000 cubic centimeter. Then you divide by the concentration or the molarity of the concentrated solution, which is now 18. So from there now, my dear students, you can calculate 0.1 times 1,000, then divide by 18. So you get 5.5, approximate is 5.6, that will be cubic centimeter. So this is the volume of concentrated or of the stock solution that should be measured. And after measuring it, is there now, you can dissolve it into distilled water and make a solution of 1 liter. But the caution to take here is that, remember that water should never be added into acid. So a concentrated acid is always added into water. So if this is your volumetric flask of 1 liter, if this is your volumetric flask of 1 liter, then you can add some water into it to a certain level, then thereafter you add 5.6 cubic centimeter. After adding 5.6 cubic centimeter, you can now continue adding water up to the meniscus. After adding it up to the meniscus, that means now that solution will contain 0.1 mole of sulfuric acid. So that is how you can prepare these, what we call it, secondary standards reagents. Now, my dear students, after having this knowledge, now let us go and consider some examples or some questions that employ you or needs you to use this knowledge in answering them. Let us go to question number 1. Question number 1 is that a stock solution of nitric acid contains the following information: the relative molecular mass 63, density is 1.42 gram per cubic centimeter, and the percentage purity is 68%. Then A, you are asked that what is the concentration of the nitric solution in the manufacturer's bottle? So that means we are supposed now to calculate the concentration of the concentrated solution or of our stock solution. I know you remember, since it is question number 1. Question number 1, where we have the percentage purity given. We have the percentage purity of the acid, which is equal to 68, and we have been given the density of the acid, which is 1.42 gram per cubic centimeter, but also we have been given the relative molecular mass of the acid, which is 63. And the A, we have to find now the concentration of the nitric acid in this bottle. That means the concentration of the stock solution. So here, do you remember that first of all, when calculating the concentration of the stock solution, you have to find out, calculate the mass of this percentage purity of nitric acid in 1 cubic centimeter. So here is that you just take up the percentage, which is 68, then over 100, that is 100%, then times the density, which is 1.42 gram per cubic centimeter. So my dear students, if you now take your calculator, that means you will have 68 divided by 100, then times 1.42. The answer that you get is 0.9656. So this is gram which are present in 1 cubic centimeter. So to find out now the concentration of the stock nitric acid, of the stock nitric acid solution, here is that if 0.9656 gram is present in 1 cubic centimeter, what about in 1 liter, which is 1,000 cubic centimeter? So you just cross multiplication, whereby it will be now 0.9656 times 1,000, then you divide by 1. The answer that will be times 1,000, you get 965 65.6. This will be gram per decimeter cubic. So this is the concentration of our stock solution, which is nitric acid. Now, to find the molarity, from molarity, which is equal to concentration, which is equal to concentration over molar mass, Here, that the concentration now we have 965.6 gram per decimeter cubic, then divided by molar mass, which is given now is 63. So if we divide by 63, you get the answer, which is 15.3 molarity. So this will be the concentration of stock solution, which is nitric acid solution. Now, part B. On part B, we are asked to calculate the molar concentration of the dilute solution of the nitric acid that could be prepared if 16.00 cubic centimeter of concentrated nitric acid would be diluted to make 600 cubic centimeter of the solution. So this is about the application of dilution law. Now, remember that on part A, we have obtained the concentration of the concentrated nitric acid, which is C1, as 15.3 moles per decimeter cubic. But we are supposed, according to the question, we have been told that if V1, 16 cubic centimeter of this concentration were taken to form the 600 cubic centimeter. So we are now required to calculate the concentration or molarity of the dilute solution. So this is dilution law. Now from dilution law, where C1, V1 is equal to C2, V2. Now we are looking for C2. That will be equal to C1, V1, then divided by V2. And if we substitute now our data, my dear students, then it will be 15 times 16, then divided by 600 cubic centimeter. So if we multiply 15 times 16, then divided by 600, the answer is equal to 0.4. That will be the molarity of the dilute solution. So do you see now how do we go about? That is question number 1, part B. Let us now go to question number 2. Question number 2, my dear students, is that Halima wants to prepare a solution whose concentration is 0.4 mole from 100 cubic centimeter of a 2 mole hydrochloric acid. To what volume should she dilute the solution? So that is what Halima did. Then we are asked, to what volume should that solution be diluted? Now, this is so simple. If we go back to our data given from the question, is that we have the molarity of, from that one, then you are supposed to calculate the volume. So we have the molarity of concentrated solution is 2 mole, and also we have the molarity of dilute solution, which is 0.4 mole. Then we have the volume of concentrated solution, which is 100 cubic centimeter. Then we are asked to calculate the volume of the dilute solution. So this is simple now. As usual, you go to dilution law. Dilution law, that C1 V1 is equal to C2 V2. Now here we are looking for V2. That will be equal to C1 V1, then you divide by C2, which is 0.4. So if we use now your calculator to calculate, that will be 2 times 100, then divide by 0.4. The answer is 500. So V2 will be 500 cubic centimeter. So this solution now, that will be measured from this solution containing 2 mole, should be diluted to 500 cubic centimeter. From there now, you will be having a solution with a molarity of 0.4. So my dear students, after that question, let us go and consider question number 3. Question number 3 is that what mass of potassium hydroxide, which is 85.9 pure, needed to prepare 1 liter of 0.25 mole solution of potassium hydroxide. The molar mass of potassium hydroxide is 56.11 gram. What mass of potassium hydroxide, which is 85.9 pure, needed to prepare 1 liter of 0.25 mole solution of potassium hydroxide? So the data we have, my dear students, data given is percentage purity, which is equal to 85.9%. Then you have the molarity, which is 0.25 mole, and you have the volume, which is equal to the volume, which is 1 liter. So it's 1 decimeter cubic, and or 1,000 cubic centimeter. Now we also have been given the molar mass, which is 56.11 gram per mole. Now my dear students, if you remember from the formula where we say that from percentage purity is equal to mass of a substance, which is of a pure substance, then you divide by mass of impure. So here we don't have the mass of impure, so we have to find it. And how do you get it? Is from, okay my dear students, but also we know that concentration, which is the mass concentration is equal to molarity times the molar mass. So here the molarity we have is 0.25, then times molar mass. Molar mass given is 56.11. So if we multiply it 0.25, then times the 56.11, the mass is 14.0275. That will be the mass concentration. Now from percentage purity is equal to mass of pure substance over mass of impure. And here we have been asked to calculate the mass of potassium hydroxide, which will be now in that one. So the mass now of impure the mass will be equal to mass of a substance given, then divided by percentage purity. From there now, if we substitute our data into that equation, then you will end up getting, it will be now, the mass will be equal to mass of a substance which is 14.0275, then divided by percentage purity given is 85.9, then divided by 100. So my dear students, if we calculate it, that 14.0275, then divided by 0.859, then the answer is 16. So the mass now will be equal to 16.3 grams. So this is the mass that we were supposed to find it. Since we have been told to calculate the mass of potassium hydroxide. So that is the mass of potassium hydroxide that we are supposed to be calculated. So my dear students, from there now, let us go to question number 4. Now question number 4 is an assignment for you to do. So you have to copy it and do it. And the question is that, what volume of hydrochloric acid with 37.1% pure and has a density of 1.2 gram per cubic centimeter needed to prepare 1 liter of 0.10 mole of hydrochloric acid solution, and given the molar mass of hydrochloric acid, which is 36.5 gram per mole. So that is an assignment question to you. But also these are references that you can use to find the knowledge of what we have discussed. We have the first, which is a new certificate chemistry, commonly known as Lambert, but also we have chemistry for you, and we have the chemistry for secondary school form 3, since the topic is a form 3 topic. So we have book 3 of written as chemistry for secondary school form 3 by Oxford University Press, and we have the last chemistry for secondary school book 2 by Tai. So my dear students, I think you have enjoyed our discussion, and I'm sure you'll have more knowledge now after this discussion in solving various questions that you'll be needed to do it. So this is Darasaonline. Thank you very much. See you another lesson.
Kipindi cha Darasaonline kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya.
This on this beat, ladies and gentlemen.
Rafiki mbusikie huu ujio, rafiki buanza kusonga mbio, achana na kiki mitandao na matukio, kwa hizi dakika chache ni azibe masikio. Kwa kifupi nitanena marudio, shayasikia kwenye televisheni na redio, na pia nina siri mshitue na mwenzio, maana uzuri wa kitu kizuri ule na wenzio. Rafiki na kutuma mpaka Ikulu, rafiki na kutuma kashukuru, rafiki bufikisha hizi duru, sikize kuna janja kukwepa ushuru, ndio maana nchi yangu imeanza kuwa na nuru. Kwa kifupi na kutuma magogoni, mwambie mjomba yale tulioota ndotoni, leo hatuamini tunayaona machoni. Ubungo Tazara siku hizi hakuna foleni, wengine wanapita juu wengine wanapita chini. Mwambie kakomesha wezi wetu wa madini, mwambie tumemwelewa watoto wa mjini.